here. It is recording. Okay, very good. All right, so this is kind of a continuation of our discussion in the lab. So what I'm doing now is I am showing you the process, the steps, to get your homework assignment done. So I'm not doing anything that is probably useful in your case. If I accidentally did something that's useful, I'm not going to take it back, okay? But I'm not intending to do anything that is directly out of your homework assignment. So I'm illustrating the technique and the tools, but not necessarily the actual solution. Okay. So I'm going to turn on the mic because I think this classroom is a little bit longer than the other one, and people in the back may not hear me as well. All right, so I think the mic is on. Good. All right, so what we'll do is we are going to start with the definitions of R and C, just as a quick review, okay? We have done that review already because the gate logic diagram that we went through earlier today already showed you the equations, just not in in text form. So I'm going to just do it here. Rxy is the result of adding x and y, and in this case, it is known as okay, since I don't have the bar notation in this case, I'm going to use a slash to mean negation. So, huh?
Exclamation mark?
Exclamation point? You guys like the exclamation point? Sure, that works. Okay. All right. So the result of adding x and y, in a half adder is not x and y, the whole thing, or x and not y, the whole thing, okay, which is also known as exclusive OR, but you're not allowed to use exclusive OR, so you have to use this definition. The carry bit, or the carry of adding x and y is easy. It's just, xy, because it's only in the case that both inputs to a half adders are ones that you have a carry of 1, so it's just a conjunction. Is that okay? So what I'll do next is I'll give myself, a artificial, kind of a setting here, okay? So I'm just going to say, okay, let me find out what is the DNF, the disjunctive normal form of this thing here. So I'm just giving myself a little thing here to work on. So I'll use a WXYZ as the potential input, so I'm not going to use X0, Y0, and so on. So we have so I'll work on the result of adding the carry of the result of WX, and then we have C YZ, and then we'll do an OR here. Okay, this is an OR with R WZ, close paren. This is closing the C, so we need one more term here, which is the R of XY, and the C of WZ. Okay. I'm just matching the parentheses here without VI to help me match the parentheses. This is a little bit harder. Okay, so I think the parentheses match. Yes, no, kind of. Okay. Okay, just count. Okay. So we have 1, 2, 3, 2, 3, 2, 3, 2, 1, 2, 3, 2, 3, 2, 1, 0. So I think it's good. All right. So now we want to look at this and go like, okay, how do we start with something like this and turn it into a DNF, okay, a disjunctive normal form. So you can work your way in or work your way out, okay? Just be consistent, okay? Whatever you do, just be consistent. So I typically like to work myself out from the inside because I like copy and paste. So if you're like me and like copy and paste, and I would work out all of this stuff using an editor first. You can use handwriting if you want, but I wouldn't do it inside LogicSim because it's just a whole lot faster by using a text editor. Okay. So I look at this and go like, okay, what is this? Okay, this is W and X. So we have not WX or W not X. Okay. And I look at this and go like, oh, that's an easy one because the carry is just a conjunction. And this one is WZ. So now we have WZ. So we have not WZ or W not Z, like that. Are we still doing okay? What?
I don't get how did you pick after C? How did you pick that it was not WX? C, like the only lines.
Oh, I was just expanding the terms one by one. In other words, I look at this RWX. It's hard not to say as WRX. RWX, and it turns into this thing here because of the definition of R.
Okay.
I look at this one here, it turns into just YZ. I look at this term here, it turns into this thing here.
Okay.
So I'm just just step by step replacing the R and the C terms by logical operations. Yes.
So why is R and C defined? Why are R and C defined that way?
RZ.
R and C. So why
Well, that's because that's the lecture of Tuesday, because this particular implementation actually matches the behavior of actually adding binary numbers. So it's the logic gate implementation of adding two numbers that are in binary.
And this is not like,
So
I thought the purpose of this was to like find a way to contract it to make it.
But before you can contract it, you have to express everything as negation, conjunction, and disjunction. That's what I'm doing right now.
Oh, okay.
Yep.
Yeah, and you want us to come at our homework this way too, right?
That's up to you. I'm just showing you what I would do if I were to have to do this. I don't think yours is that complicated. Maybe it is. I don't. It's not as complicated as a 3-bit adder.
Okay.
So last year it was a lot more cumbersome because of that. Okay, so now I'm going to convert this one into, this is a XY, so it's X not XY or X not Y, okay? And this one is just WZ, because WZ is, the carry of W and Z is just WZ as a conjunction. So that's the second step. And then the third step, okay, is going to be a little bit more cumbersome because I will have to take, this is the carry, okay, so you have to look at the parentheses and commas and stuff like that very carefully, because this carry has this as the first parameter and this as the second parameter. That's what the carry has. So when you work on this, when I work on this, I just use copy and paste, and I just say, okay, I want to take care of this entire carry operation. Carry is the easy one, because all you're doing is you're turning this into a conjunction of the two parameters. So that makes it a little bit easier, because we just say, okay, let's take out the C here, and then we basically just add some parentheses to make it clear, and then take away the comma, and that turns it into a conjunction. Okay? And then the other one, question? No questions? Okay. So the other one is this one here. Okay, this is this is going to get a little bit more hairy, because the R is exclusive OR, so you have to negate the first conjunction with the second, and then OR. The first one non-negated, and then negate the second. Okay, so that's going to be a little bit more cumbersome. And the way I do this is it's like this. Okay, so I basically take this away a little bit, or you can just replace it because you know which part you're working on. So I'm going to take this away completely. But I know the general form is going to look like this. Okay, it's going to look like the negation of the first term, conjunction with the second term, the first term non-negated, and then negate the second term. So I know this is going to be the general format. Okay, and knowing this is the general format, now I can say this is my first parameter. It belongs here and here. This is my second parameter. It belongs here and here. Okay. Now, before it gets really, really ugly and complicated, you might want to do some simplifications first. Okay. Now, what I mean by simplification is you just look at one of these nasty things and just say, okay, that looks really nasty. Can I re-express this in a way that is less nasty? Okay, it's already easier to read. So you can do that. For instance, I look at this term here, and I go like, well, can I make this look a little bit nicer? So let's go ahead and give it a try. And there are techniques of simplification that you can use to make something like this look a little nicer. So we will take this thing here, okay, and I'll do it on the side. Okay, and just say, okay, can we do something about this first? So you can see that the reason why this is not DNF, or nasty, is because we have a conjunction here, and then we have the disjunction in the inside, and then conjunction in the inside of that. So we will use the distributive law to deal with this, to expand it. Okay? So the distributive law, we'll look at this, and the law of associativity works too. In other words, when you have a sequence of disjunction, how you put the parentheses really does not matter. What that means is this pair of parentheses can go, because it doesn't really matter whether you use the disjunction on the first two terms first and then do the disjunction on the third one, or do the second and the third term and then do the first one. It doesn't really matter. The ordering does not matter. How you nest does not matter. So that makes it a little bit easier to read. So when you look at this, it will end up with 6 individual terms separated by disjunctions. So each one is going to be like this. And I'm lazy, so I would just do this. 1, 2, 3, 4, 5, 6. Okay. So that becomes the overall template. Yep.
You're recording, right?
Yes, I think I am.
Double check.
I'll double check. I will double check. Okay, so it is recording, and the recording is on. Okay, but this is technique. Okay, this is all about technique. And what I will also do is to break it up into 2 lines, where the first line deals with the first term of the left-hand side, and then the second line will deal with the second term of the left-hand side. In other words, I take this and say it's here, here, and here. I take that and say it is here, here, and here. Yep.
I just wanted some clarification. So this is all going into one OR gate?
At some point, I'm converting this whole thing into a huge disjunction on the top, a bunch of conjunctions, below that, and then the conjunctions only hook up to either an input pin or the negation of an input pin.
So at the very end, is there only one output?
This is only for one single output, correct?
So is that supposed to be like the carry bit?
The carry out is going to be the most ugly one. Well, let me see. Maybe it's either the last carry or the result, the most significant of the result. I don't think you have problems as complicated as this. Okay, but I could be wrong.
Oh, so this is more complicated than our homework?
Could be. I just threw this out
Okay.
just so that I can work on it. Okay, so getting through this, so now we can say, okay, this is the first term, it goes here and here. This is the second term. It goes here and here. And this is the third term, it goes here and here. Okay, but do you guys see how I did it systematically?
At some point, I just completely lost you.
That's okay, it's recorded. It is recorded. It's going to be on YouTube. But the point is, I make it systematic. Okay, I have a particular way to do it. I look at the first term of the conjunction, and I say, okay, I use one row to deal with this guy. I use the second row to deal with this guy. So by knowing which row, I know what is supposed to be the first term. So you can see not Wx, not Wx, not Wx on the first one, and then we have W not x on the second one. And then I look at the second term and go like, okay, this is distributed on each row. So YZ is here, and YZ is here. Not WZ is here and here. W not Z is here and here. So by making this systematic, I won't be missing anything. And when I copy and paste, it is also a very mechanical operation. So it is less likely for me to make a mistake in the process of doing this.
I get what you're doing. And if this was regular algebra, it'd be so much easier, but it's like there's a different kind of logic to it that makes it hard to follow.
Well, you're still mechanically applying the rules. Okay, you're still mechanically doing everything. It's just that some of the rules have changed a little bit, but for the most part, it is really the same as the algebra that you already know. So the only tricky part is
the distributive operator that you go along.
and also De Morgan's law. De Morgan's law is the only one that is really kind of awkward compared to your usual algebra.
But even that's it's still the distributive process.
It's distributing the negation. Yep. Okay, so when you look at this, you go like, tech, I think we're going backwards because we started off with something that looks like this, and now we have something that looks like this. Holy smokes, what is going on here? So what you do is you simplify. So you look at this, and then you say, can we simplify this? And you do it term by term. Don't look at this whole thing and go like, oh, this is impossible, I've got to give up. Okay? You gotta have to look at this and go like, okay, I will just work on it one step at a time, and I'll be done. Okay? So you look at this part here and you say, can we simplify this a little bit? The answer is no, because all four terms are different. So there's no possible way for you to simplify. So you just have to keep it, and you just say, okay, this is just it is what it is. It's not w x y z. Okay, that's the first term. Nothing I can do about this. And then you look at this term here, and you go like, well, can I simplify and make it look a little nicer? And the answer is yes. Because we have not w on both sides, well, you don't have to say it again, right? Not w and not w, it's just not w. So you combine the two not w's into one single not w, and it becomes a little bit easier. So the second one is just not w, x, and z. And then you look at this one is nice. I like this one. Because it simplifies to
W.
nothingness. Because it has got w and the negation of w in the same conjunction. Now, by reordering the terms a little bit, you can end up with not w, w, or if you prefer w, not w. But nonetheless, it is the conjunction of w and its negation, which is guaranteed to be false. So this whole thing just goes away. It disappears. Okay? So now we move on to...
It isn't turned to XZ.
Huh?
Like the W.
No, because it's a and.
Yes, and with a zero.
Because it's a conjunction. This whole thing is one huge conjunction.
It says not W and W.
And some other stuff. But
So by using, okay, so if you want to go step by step, you use the associative law to dissolve the parentheses, and then you use the commutative law to move the W next to the not W, and then you simplify W not W into a zero, and the zero and whatever is always zero, so this whole term just goes away. So you really just have to kind of study the Boolean algebra cheat sheet a little bit, so that you can learn all of these techniques. But that's part of why I'm doing this, because I'm showing you what can be done to make it look nicer and simplify all the terms. So if you prefer, because it will just count up to the right number of items, I'll just put a 0 here, just so that, okay, we have already accounted for that term that simplifies to false. Okay, so now we look at this one. There's nothing you can do about this, because each term is different, so you cannot simplify this one. So we'll just copy it the way it is. And then with this one, it's the same situation. Because we got a W here and a not W on the other side, it becomes a 0. And then we look at the last one. We can do a little bit of simplification, because we got a W here and a W here. We only need one. So we can simplify this a little bit, so it becomes W not X and not Z. Okay? Is that okay? So now you look at this and go like, well, all the zeros can go away. There's no need to say or false. Yep.
Do you scroll down a little bit?
Oh, sure. Oh, I can't scroll down because this is the last line, but what I can do...
You hit enter.
You just add a bunch of entries at the bottom.
Say again?
You can add a
But this works, right?
Yeah.
Yeah. Okay. So now I can simplify this one more time, and this is why I would do this inside a text editor, because you can actually just do this. It's easy to copy and paste. So now I went from something like this, which is not too bad, to something that looks like this, which I think is better. Okay? So I can do the same thing with the other term here. So we'll take a look at this chunk here and see what we can do with it. Okay, copy and paste. There we go. Okay, now this one requires the use of De Morgan's law, because we have a negation on the outside, and the negation of the outside is the result of using the or operator, because that requires you to negate either the first one and then negate the second one. Okay. All right. So we just have to make sure that we are very clear about the ordering or the nesting of the parentheses. So this is one term, and this thing is one term here. Okay. Did I do something?
You just moved WZ.
Okay. So we look at this whole thing. This is another term. And this negation applies to only the first part. It only applies to this one here. Okay? So what we need to do is just to do this step by step. And the best thing of using a text editor is you can actually just copy and paste. So do very little on each step so that it's harder to make a mistake and not notice. Okay? All right, so we'll do it step by step. And I'll copy this whole line to the second line. And I'm just going to say, well, I'm not going to be doing everything. I'll just deal with this term here. And the only way to deal with this term is to use De Morgan's law. Okay? So when you use De Morgan's law, it will basically be distributing the negation to the inside. And in this case, it will turn the disjunction into a conjunction. So I already know what it looks like. I know it's going to look like the negation of the first term and the negation of the second term. Okay, that's what it's going to look like. And it has a conjunction with WZ. We can keep that, okay, because you can stack conjunctions together. That's not a problem. So what I'm negating here, what is the first term? The first term is this entire thing. I copy it over here. And then the second term is this entire thing. I copy it and paste it over here. Now, if I don't want to be too ambitious, I'm just going to stop here, of that particular step, and I copy and paste it here. And this time I will go like, okay, what else can we do about this, or what else needs to be done? You look at this, and you can see that this negation applies to a conjunction. This negation applies to a conjunction. We don't like negation applied to an operator of any kind. The only time we can use a negation is on a particular pin. In this case, represented by W, X, Y, or Z. So we have to apply De Morgan's law again. And this time, it's going to be the other way around. So it's going to be not something or not something. And that will take care of the first term. So this term is going to go away because it becomes this. So not X is the first one, and then Y is the second one. Okay, does everybody see how I apply De Morgan's law? Let me just highlight which portion I'm talking about. I look at this and say, I don't like a negation on the outside or negation applied to conjunction. So I apply De Morgan's law so that it would become this. This is the result of applying De Morgan's law. It just looks a lot uglier because I have a lot of extra parentheses that are not necessary. So the next line, I'll just do some simplification and say, okay, I don't want to look at all those extra parentheses that are not needed. I look at this and go like, hey, the negation of X is just X. Okay, very good. And this is just negation of Y. There's no need to use the extra parentheses. So now I just make it look cleaner. Okay? And if I don't want to confuse myself too badly, I just say, okay, the next step is going to deal with this one here, which is the same deal. Okay, we have to apply De Morgan's law and turn this into a disjunction of negated terms and not a negation of a conjunction. So we look at this and go like, okay, we know what it's going to look like. It's going to be a disjunction. where we have a negation of individual terms like that. So you can see what I'm doing here is I am giving myself a template so that I know how to copy and paste the individual files. Okay? Now, how you want to do this is entirely up to you. It's just that in my case, I have found that this works out really well for me by generating the template first and then go back and backfill the structure itself. Okay? So then I look at this and say, okay, can we simplify this so that it doesn't look as ugly? Well, sure. This pair of parentheses is not needed. The negation and the negation of y is just y. So now it looks a little bit cleaner. Are we still doing okay so far with this progress here? Okay. So now I look at this. I still want to work on the first term a little bit more. And I say, okay, this still doesn't look very nice because it's a conjunction of individual terms that can involve a disjunction. So we will deal with this. Okay, so we'll go ahead and deal with this one. And I'm going to deal with this part here first. I will use the distributive law to take care of this operation. Okay. So in this case, because we have we will end up with 4 terms separated by disjunctions. So we'll just go ahead and say this becomes something plus something plus something plus something. And this is the, yeah.
Just looking at that term, when it has parentheses like that, that's a conjunction, right? Because isn't that always going to be false then? Does it say?
Which one?
The one we're working on right now. X or not Y. Conjunction, not X or Y.
No, why would it always be false?
Because it's a conjunction. Never mind.
Well, when we spell out the terms, if it does simplify to false entirely, it should be obvious once we work on the terms. Okay, so we'll work on the terms, and the way I do this is I specify x, and then not y, and then and then I use the second term here. So this is not x, this is y, this is not x, and this is y. It's just a cross product. It's a cross product where items in the left hand side is here. Items from the right hand side is here and here. Is that okay? Okay, okay, I'm applying the distributive law to this expression here. Now, and this is really just the same as arithmetics. Okay, in normal algebra, you can use distribution like this. Is that okay? Are there any questions, from going from here, where I highlight on the projector, to here? It's just a cross product. Another way to look at the cross product is to use a table. Okay, so what you do is you say, okay, what is A plus B times C plus D? That's basically what we're looking at, even though they're in X and negation of X. So what you do is you use a table, and you say, okay, AB goes here, CD goes here. So what is the combination of each cell? Is just AC here, BC here, AD over here, and BD over here. And you can apply the same thing over there, where we have X, not Y, and then we have not X, Y, right? So then you end up with 4 terms. The first term is X, not X. The second term is X, not Y. Oops. Take it back. Second term is not Y, not X. And then over here we have XY, and then Y, not Y. So that's how I end up with those terms. 4. Okay. So now we can simplify, because whenever we see in a conjunction, we have a variable and its own negation, it simplifies to 0. Okay, so let me just make a new line for this. So this way, when you look at the video, it is actually really step by step. Is that okay? Because I just took out x not x and not y y. Okay. So once you take out those terms, I'm really doing this step by step. So taking out the zeros is its own step. Is that okay? So now we can distribute one more time because we want to incorporate WZ into it. So now it becomes WXYZ plus W not X not Y Z. I'm just reordering the letters so that it's alphabetical. And that becomes the first term. So now I have time to work on the second term. The second term is easy to work with, well, sort of, but we still have a De Morgan's law to apply because we have a not WZ. The negation is applied to conjunction, so we have to apply De Morgan's law to take care of that first. Okay, so I'm not going to do any more simplification on the same line. We'll separate it into 2 lines, just so that it is kind of really step by step. So we look at this and go like, okay, this is what we want to deal with, and it becomes the negation is distributed in the inside. The conjunction becomes a disjunction. It's the application of De Morgan's law. So it becomes not W or not Z. Is that okay? All right. And now we look at this whole thing and say, can we do something about this side? Well, we can apply the distributive law again. Okay. Oops. So when you apply the distributive law, it becomes 4 terms that are connected by disjunction, and then each term is going to have 2 parts. The first part is contributed by this. Okay, so we'll have this here, and then this is going to be over here. And then I just alternate the not W and the not Z. There we go. Are there any questions about this part? It's still good? All right, okay. So,
They foiled it.
So this is one conjunction term, and this is one huge a disjunction term. So they can all be combined into one single one now. So just look at all these terms and say W X Y Z plus W not X not Y Z plus this one is not W not X Y plus not X Y not Z plus not W X not Y plus X not Y not Z. Okay, so it becomes this term, and it may or may not be able to be simplified any further. I'm just going to look, okay? And to make it easier to read, I'm going to use some spacing like that. Okay, so now that it's spaced out, we can try to see if there's anything we can do to simplify this. I don't see any particular way to simplify this any further. Yeah, so it doesn't look like it can be simplified any further, so we'll just leave it as this. Okay, so we take this whole thing and we say, okay, where was it supposed to go? It's supposed to replace this thing here, and that is the second term. So now we can say this becomes one big huge R, and you guys are going to hate this, where the first thing is this. And the second thing is this. Now, I really think this is actually unnecessarily complicated compared to your homework assignment, but I'm just showing you the tricks that you can apply to simplify things and to basically know what to do when your equation looks like this. What can you do about it? When your expression looks like this, what can you do about it? Yep.
When would this be used?
When?
Yeah.
Well, when you get everything resolved, then you end up with a DNF, a disjunctive normal form. Then you end up with the gate logic hierarchy that we were talking about, where you only have up to 3 gates of propagational delay. So that's why we are doing this, because we are starting with the definition of the R and the C, and end up with some really kind of gigantic and complicated expression. But we want to turn that really complicated expression into DNF, just so that we can do logic gate design. I don't think it's going to work out this complicated for your homework assignment, because I'm just digging through my notes here so that we can take a look back at the equation or the formula that we have been working on. This looks more complicated than what I did last year, so it's a clue that it may be a little more complicated than it needs to be, but it's a demonstration. In other words, remember, it makes no sense at all. Okay, it doesn't relate to your homework assignment directly. It's just that the technique does. So if I go back to the notes that we captured earlier, let me make sure that we can see the whole thing. Oops, I just dropped the. Just want to make sure I don't accidentally take a picture of myself and put it on YouTube. There we go. Okay, so this is your homework assignment. When you look at your homework assignment, the most complicated one is most likely to be this guy here. Because this is the R that combines this term, which is a little bit nasty but not too bad, and this term here. This term is the C of this term and the C of this term, with an OR. So I would say this is the most complicated part of your homework assignment. Not the overall carry, but the most significant bit of your result. So let's just work this one out here. We worked it out once already, but let's do it one more time just so that we can see, okay, so how complicated is that, okay? And I'm just trying to figure out, whether to put it on the same piece of paper or not. Well, okay, I guess we can just do it here, since I have an eraser.
Oh, wait, that's all we're doing?
Okay. R, x0, y0 goes there, because when you trace the line, it goes from here. This is going to be the more complicated one, because it is the carry of adding x0, y0, or the carry of adding r, x0, y0, and c in. R, x0, y0, and c in. Okay? And that's the most complicated term that you have to deal with in your homework assignment. And I think this is simpler compared to the example that I went through.
Yeah.
Considerably. It's still not a breeze, it's still not a very easy walk in the park, but I would say it's not nearly as
But if I
bad.
understand what you did on that hard example, then this
Exactly.
will be a lot.
It's the process, how to do it that is important. And for those of you who say, I cannot read this at all, well, it's okay, because we did it on the other day as well. We did it on Tuesday. So this is not going to be the only time, but occasionally I would do this. I would go to
probably want to make it a private window because otherwise the cookies may mess up. So I'm just going to go to YouTube
Yeah, I think
and go to some props. There we go. And then when you look at the videos on Tuesday, cisp310 on Tuesday, toward the end of the class, before that. Yep, I think that's it. We got okay, it's a little bit different because we had a assumed bit 0 as C in, so that's why it looks a little bit different. Okay, I'll just kind of give this to you. I'll give this one to you guys. And I'm going to do it in a text editor just because it's faster for me to write it this way. So I'll give this one to you for the 2-bit adder. We got x1, x0, y1, y0, and this is the add operation. And this is our C in. And I'll only give you the ones that are actually important. Okay, so what goes here? What goes here is going to be the result.
R, x0, y0.
Not quite. This one here is R, x0, y0. That's what it is. So this one is going to be the result of adding x0, y0, and C in. Right? Okay. This one here, okay, I'll just call this, give it a name of A, okay? Okay, what is A? A is going to be the carry of adding 2 bits or the carry of adding 2 bits. The first 2 bits will be x0, y0. The second one will be these two. So one is called R, x0, y0, and the other one is just known as C in, which is an input pin. Is that okay? All right. And I claim that this one is going to be the most complicated one. We'll just call it B. So we look at B and say, okay, what should it look like? It is the result of adding 2 things. It's the result of adding this bit to A. We know what A is already, so we just say, okay, we'll just copy and paste A over here. And then this part here is really just R, x1, y1. Right? Is that okay? Now, how does this compare to what I just did earlier?
But then you can do better.
This is not as bad, because you don't get really complicated stuff for the first term of the overall R, and that's where things get really bad, is when you have long and complicated terms to feed into the R, because one has to be negated, the other one is not negated, and then you have the flip side. So that's what things can go really bad. But this one is not too bad because you have to, if you have to negate this one, it's not too bad. This one looks really nasty, but it really is not. Because if you remember, a carry is really just a conjunction. So it looks a lot nastier than it really is. And then the overall carry, which coincidentally has a symbol of C, is going to be the carry of adding 2 bits or the carry of adding 2 bits. The first one is easy because it's just x1, y1. And then the second one is between this bit here and the one and the A over here. The A, we already know what it is, so we just copy and paste this over here. And then the other one, okay, the other one is this bit here, and we figure out what that bit is already. It is just R, x1, y1. So we copy that and put it here. So this slide tells you everything that you need to know to start with your homework assignment. And if you think about it, it really is not nearly as nasty as what I demonstrated earlier. I would just take care of the C with simple terms first, because that's just way easy to take care of. Once you take care of those, then things won't look as bad, on the screen. Yep.
The E equals line.
Uh-huh.
Do you have an extra parenthesis?
Let's check that. No, I'm not missing anything. Okay, this is an overall R, so you have to look at what feeds into this R. The first term that feeds into this R is R x1, y1, and then the second term to feed into that R is this whole term, which is a disjunction of 2 carry bits. Now, for those of you who are more kind of visual, you can kind of look at this in a different way, so you can use indentation to help you look at this whole thing. So you can say, okay, it looks like this, right? Is it helping? By using indentation and multiple lines?
Oh, okay.
Okay, are there any questions about the homework assignment now that I gave you the exact starting points? Which, yep, go ahead.
So each of our outputs is a DNF. So we'll have several DNFs that we have to do.
That is correct. Each output pin corresponds to a DNF expression, and as a result, you end up with 3 disjunctions, or 3 DNFs.
Okay. So then like C would be a DNF, and that would be one of our output pins. D would be a DNF, and that would be one of our output pins, and we'd have so on and so forth.
Right, so in your homework assignment, this will turn into one single DNF, this turns into another DNF, and this turns into the last DNF. So that you will end up with, so each DNF is represented in the gate logic diagram by a kind of big disjunction and being fed by conjunctions. And then the only thing that can be in the conjunction are the input pins. But you are allowed to use the bubbles with a conjunction to negate the input, not the output. So is that good? Okay. Any other questions?
Can you scroll up a little bit?
Absolutely, and there was a question from, yep, back there.
So it's a 2-bit adder with like a 1-bit overflow? Is that one way to describe it?
This is just the overall carry, because I want to know whether I ran out of bits as a 2-bit number. And that's why you have 3 outputs, because you have 2 output pins and then 1 extra output pin as the overall carry. Okay. Any other questions? Any special techniques? Let me just go back to the homework assignment. Are we done with this slide? I mean, do you guys want to stay on this one? Once again, there really should not be any need to copy this, because I have faith that I am recording this. Okay, so what if I do not, I'm not sure that I'm recording this or not. I don't want to wait until the end of the class to find out that it's not getting recorded properly and so on and so forth. If I'm not recording this correctly, I want to kind of make sure that, do something about it. So what I can do is I can actually play what I'm recording right now using VLC. It actually works. The only reason why this looks kind of confusing is because I'm playing the same thing that I'm recording earlier. So I can fast forward the whole thing to the very end here, and you can see, yes, it is recorded. And the voice would actually play as well if I turned it up.
Oh, you also have to put up the volume on here.
Oh yeah, crank up the volume here. Uh-oh. Why is it not?
Because you're still recording?
No. It doesn't have to be like that. It should play the voice as well. I'm just checking the input to. Okay, I think I know. Okay, let me see if I can fix this. I think it's because the output device is not chosen. It's not choosing the one. There it is. That is highly suspicious. Oh, playback. There we go. Okay, so we have to look at playback, and it is using a built-in audio, and well, that should be the correct one. Okay, look at output devices. The volume is great out here because it's muted.
A kind of vague disjunction and being fed by conjunctions. Okay, so we can do this all day long, you know, and I can play another one of this recording and play another one of this recording. I mean, you know, even I cannot tell whether I'm looking at a video or is this the actual editor, right? So I would try to click on this and go like, let me change this. Oh no, my mouse pointer just moved on its own. Somebody hacked my computer. Okay, so, but, you know, just, oh, it's still playing even though I closed the VLC. Now that's a little disturbing. Somebody just left the room when I was recording that. But I stopped VLC already. How come it is still playing? Okay, this is the video. This is the document camera. So if I kill this one, it would just kill the document camera. So I'm not sure why it is still playing. I can check that. 10:30. That's right.
It's the VLC tab up there at the top.
So this classroom has a mic.
Oh, this is the other one. This is from Tuesday.
It's that right
If I
there.
can find a microphone.
This is from Tuesday.
It's
I'm
in your-
confusing myself.
It's in your yeah.
There we go.
So I was playing the video from Tuesday, and then I played the video that I'm currently recording. I closed the playback of the video that I was recording today, but then I forgot that I was playing on from YouTube as well. So I go like, how come it's not closing? How come it's still yakking? You know, I'm hearing voices in my head, and so are you. You know. All right, so are we okay? I mean, are you guys feeling at least you know where to start? The homework is due in a week, so what my suggestion is to get on it as soon as possible, okay? And if you need me to check on something, like, okay, I start from this, I end up with this. Now, don't go through like 20 steps before you say, okay, is this the same as this, okay? Because I'm not going to follow that. But if you have individual steps that you want to show me and say, okay, can we go from here to here by applying the Morgan's law, I can check that. That is not a problem. But if you go through like 20 steps and go like, can we go from here to here without showing me any steps in between, I cannot check that. Yeah, there was a question back there. You got it? Okay. So are we okay or not? Okay? So I would, the other thing is when you do this derivation, you can also kind of double check sometimes, especially with the simpler ones. Just look at the starting point, look at the ending point, and just give it some sample values and see whether you get the same results back or not. Okay, if you do, then you have some confirmation that it's working. If you don't, then you know that you might have made a mistake. Okay, so I'm gonna stop the recorder and upload everything before I forget. So let's see, go back here or here.